Hello, going through the AQA GCSE Physics Higher Tier Paper 1 from May 2018, and today we're going to go through question number 10. As ever, feel free to start and stop as the video goes on so that you can move on at your own pace. So question 10, figure 16 shows a wind turbine, 10.1, at a particular wind speed, a volume of 2.3 times 10 to the 4 meters cubed of air passes the blades each second. The density of air is 1.2 kilograms per meter cubed. Calculate the mass of air passing the blades per second. Now we're at the end of the paper, there are going to be some questions that are there to trick you. So we've got a volume of air each second, and we want to find the mass of the air each second. So we've got density, so density equals mass divided by volume. Now that's the same as saying density equals mass per second divided by volume per second. So the per second becomes irrelevant because they cancel through. So if we now rearrange that because we want to find the mass, so the mass per second equals the density multiplied by the volume per second. So that's 1.2 times 2.3 times 10 to the power of 4. And if you put that into a calculator, that will be 27600, or 2.76 times 10 to the 4. For question 10.2, the power output of the turbine is directly proportional to the kinetic energy of the air passing the blades each second. Describe the effect on the power output when the wind speed is halved. So again, a tricky question, but if we look for a clue, in the question it says power is proportional to the kinetic energy, or if we think about what kinetic energy is, that's a half times mass times velocity squared. So now, if you're travelling half the speed, that means that you're only going to have half of the mass passing through per second. So the mass by itself will decrease by a factor of 1/2. But we're also going to reduce the speed or the velocity. Now that has a v squared term. So that means if you halve the velocity or half the speed, that means you're going to be left with just a quarter. It's going to reduce by a factor of a quarter, because 1/2 or 1/2 squared gives you a quarter. So therefore, because the mass goes down by a half and then the velocity goes down by a quarter, that then leaves a factor of an 8. So the kinetic energy decreases by a factor of 8. Tricky. Question 10.3. At a different wind speed, the wind turbine has a power output of 388 kW. The mass of air passing the wind turbine each second is 13,800 kilograms. Calculate the speed of the air passing the blades each second. Assume that the process is 100% efficient. So again, finishing off with a very tricky question. So we've got a power output. Now the first thing to remember is kilo, so that's 388,000. So I've multiplied that by 1,000, turn it into watts. So we've got a power, we've got a mass, we want to find the speed. Now, given what we've just been going through on the previous question, look for clues. So power was mentioned on the previous question, and so was kinetic energy. Now, there's a link between power and energy. Energy equals power multiplied by time. And likewise, if I rearrange that, power equals energy divided by time. Keep that at the back of your head for the moment. Also, kinetic energy equals a half times mass times velocity squared. But we want to find the speed of the air passing each second. So if I now do kinetic energy per second, that's then equal to a half times mass times velocity squared per second. So what we've got is a situation where we can put the two equations equal to each other, because energy over time is the same as kinetic energy over time in seconds. So by putting the equations together, we can have power equals kinetic energy per second. So the power is 388,000, and then that's equal to a half times mass, which is 13,800, and then we're trying to find the speed. So that's then 2 times 388,000 divided by 13,800. That still equals v squared, which is 56.2. So to find the velocity, we need to square root, and that then equals 7.5 meters per second. So we're now at the end of the question and also the paper as well. I hope you found it useful, and as ever, any questions, please get back to me.